Welcome to A Square Maths by A2 E2 Laplace Transform Part 5. In this session, we are going to see Laplace transform of integrals and derivatives of f of t. First property. If Laplace transform of f of t is equals to a bar of s, then Laplace transform of integration from 0 to t f of u du is equals to 1 upon s f bar of s, provided that d by dt integration from 0 to t f of u du is equals to f of t, that is f of 0 is equals to 0. Let us take a proof. Let Laplace transform of integration from 0 to t f of u du is equals to integration from 0 to infinity e raised to minus st integration from 0 to t f of u du into dt. Integration by parts to RHS, we get integration from 0 to t f of u du e raised to minus st upon minus s, limits will be from 0 to infinity, minus integration from 0 to infinity d by dt of integration from 0 to t f of u du, and integration of e raised to minus st is e raised to minus st upon minus s dt. As far as limits of this term concerns, upper limit will be a 0 as e raised to minus st is 0, e raised to minus infinity is 1 upon infinity, that is 0. And as we have given, if we put here t is equals to 0, limits of the integrals are from 0 to 0 will be a 0. Limits are same of the integral, so the value of that integral is 0. Here in the second term, let us take 1 upon minus s outside. So that is 1 upon minus s integral from 0 to infinity. And as we have given d by dt of 0 to t f of u du, the value of this term is f of t, since f of 0 is equals to 0, we have given this. So by definition of Laplace transform, this integral from 0 to infinity e raised to minus st f of t dt is nothing but f bar of s, and hence it is the proof of this property. Next, Laplace transform of d by dt of f of t. Let Laplace transform of f of t is equals to f bar of s, and f of t is continuous function and is of the exponential order as 0, that is limit s tends to infinity e raised to minus st f of t is equals to 0 for s is sufficiently larger than s0. Then Laplace transform of d by dt f of t is equals to s f bar of s minus f of 0. Proof. Let Laplace transform of d by dt of f of t is equals to integration from 0 to infinity e raised to minus st d by dt f of t dt. By definition of Laplace transform, we have taken this one. Let limit m tends to infinity 0 to m e raised to minus st d by dt f of t dt. Now let us apply integration by parts here. Limit m tends to infinity e raised to minus st, and integration of derivative is only f of t here. Limit will be from 0 to m, minus m tends to infinity integration from 0 to m minus s, derivative of e raised to minus st, integration by parts, e raised to minus st f of t dt. Hence, as we put limit in this term, we will get limit m tends to infinity e raised to minus sm fm f of m minus f of 0. But this term is nothing but 0, that we have given given exponential order s0, and this term will be the as it is. In the next term, this minus s you can take outside, and hence we got the answer directly. Laplace transform of d by dt of f of t is equals to s f bar of s minus f of 0. Let us see some examples on these formulas. Find Laplace transform of integration from 0 to t hyperbolic cos of 2t cos of 3t. Let f of t is equals to hyperbolic cos of 2t plus cos of 3t. Hyperbolic cos of 2t can be written as e raised to 2t plus e raised to minus 2t by 2 cos of 3t. 1 by 2 e raised to 2t cos of 3t plus e raised to minus 2t cos of 3t. So, now let us find the Laplace transform of cos of 3t. So, Laplace transform of cos of 3t is equals to s upon s square plus 3 square is equals to s upon s square plus 9. Then let us take this term to find the Laplace transform. Therefore, Laplace transform of e raised to 2t cos of 3t plus e raised to minus 2t cos of 3t is equals to whatever the Laplace transform of cos 3t, there s will be replaced by in the first term by s minus 2, and in the second term s will be replaced by s plus 2 by first shifting property. Hence, the Laplace transform of these terms will be equals to s minus 2 by s minus 2 the whole square plus 9 plus s plus 2 by s plus 2 the whole square plus 9 by first shifting property. Next, therefore, Laplace transform of integration from 0 to t hyperbolic cos of 2t into cos of 3t is equals to 1 by s will be replaced since we have the formula Laplace transform of integration from 0 to t f of t dt is equals to 1 upon s f bar of s, and hence this term will be as it is, only 1 by s will be prefixed, and hence Laplace transform of integration from 0 to t hyperbolic cos of 2t into cos of 3t is equals to 1 upon 2s s minus 2 upon s minus 2 the whole square plus 9 plus s plus 2 upon s plus 2 the whole square plus 9. Find Laplace transform of integration from 0 to t raised to minus 1 e raised to minus t sin of 3t dt. Here we are supposed to find the Laplace transform of integral with the multiple of trigonometric function, exponential function and algebraic function. So, as usual, let us find first Laplace transform of sin of 3t. So, let f of t be is equals to sin of 3t, and therefore Laplace transform of f of t is equals to Laplace transform of sin of 3t is equals to 3 upon s square plus 3 square, that is equals to 3 upon s square plus 9, since Laplace transform of sin of at is equals to a upon s square plus a square. Therefore, Laplace transform of f of t by t, because here is t inverse and t inverse can be written as upon t, therefore Laplace transform of sin of t upon t is equals to integration from s to infinity 3 upon s square plus 9 ds, and integration of 3 upon s square plus 9 is tan inverse of s by 3. Limits will be from 0 to infinity. Here we have applied the formula Laplace transform of f of t by t is equals to s integration from s to infinity f bar of s ds. Let us put limit tan inverse of infinity, and this will be a tan inverse of s by 3 for lower limit. But tan inverse of infinity is pi by 2, and this term, and let us apply exponential, that is first shifting property. We will get e raised to minus st, that is here s will be replaced by s plus 1 by 3. But pi by 2 minus tan inverse of s plus 1 by 3 is nothing but cot inverse of s plus 1 by 3. So, Laplace transform of integration from 0 to t e raised to minus st sine of 3t by t dt is equals to 1 upon s cot inverse of s plus 1 by 3 by the formula Laplace transform of integration from 0 to t f of t dt is equals to 1 upon s